Hello there and welcome to this course on healthcare data wrangling with Python. My name is Valentine and I'll be your instructor. In this course or in this workshop, we are going to go through this structure. So we'll be first of all going through the learning outcomes. Then after that, we'll get to learn about what healthcare data wrangling entails using Python and why we perform the related concepts. After that, we'll go into a practice session that will allow us to practice those healthcare data wrangling techniques using the Python programming language. We'll provide examples as well as challenges that will allow you to acquire those skills that we'll have set out to achieve. Then towards the very end, we'll talk about just the next steps, like what makes sense to now undertake in terms of the learning once you have done a course in healthcare data wrangling with Python. All right, so let's get started. By the end of today, we are expected to have achieved these learning outcomes. So we should be able to explain the importance of healthcare data wrangling and its applications in relation to Python programming. We should also be able to also explain its importance in the data analytics as well as the data science aspects in relation to healthcare. We should also be able to demonstrate proficiency in using Python basics for healthcare data manipulation and analysis. So we will be in a position to practice some concepts that we might have learned in the past in relation to Python. Lastly, we are expected to have been able to apply data cleaning techniques, handling such as handling missing data, removing duplicates, and outlier removal methods. So we should be in a position to apply those methods using Python for purposes of handling healthcare data. So essentially what we are going to be performing as part of that application is handling or performing this process that's usually called data pre-processing, but now in the context of healthcare. So those are the learning outcomes. By the end of this course, you should be in a position to say that you've achieved all those learning outcomes. Starting off, what is healthcare data wrangling? So healthcare data wrangling generally refers to that process that we undertake when we are working with data in relation to healthcare. And this process would involve either data collection, cleaning, or generally organizing healthcare data from different sources for further analysis. And healthcare data usually comes in different formats. It could be from electronic health records, maybe in CSV data format. It could also come in the format of medical imaging data or its related data, metadata. It could also come from wearable devices. Maybe you might have smartwatches. It could also come from administrative databases, from maybe HR or operations department databases that handle matters operation within not only a hospital, but just generally a healthcare institution. It could also be maybe a research institution still in the context of healthcare. So generally, healthcare data wrangling just refers to that process that we normally take in order to prepare data for further analysis. It could be for maybe creating analytics reports, or creating visualizations or machine learning models. So so this workshop should help you understand how to perform those techniques that are in relation to data wrangling. A few examples of healthcare data wrangling activities that we tend to perform include possibly exploring a data set, a healthcare data set that we might have, in order to identify patterns, trends, anomalies that would, as a result, inform subsequent analysis. It could be that another activity involving healthcare data wrangling would involve gathering data from different sources, say from structured data sources such as maybe databases, or unstructured data sources that might involve maybe images or even just text data that has been keyed into just different data sources. It could also mean maybe just identifying or correcting errors or inconsistencies in data. Maybe you might want to identify what missing values there are in data, what duplicates there are in data, or even just any other inaccuracies that you might have. Why would we perform healthcare data wrangling techniques? There are various reasons. The first one would be quality assurance. So healthcare data normally would come from just different sources. It could be maybe from electronic medical records that we've talked about, maybe administrative databases. And we would want to ensure that we standardize maybe the format that the data comes into, so that we have data that can be further used for analysis in an easier way. So for data quality assurance, that would be one of the reasons. Data integration, sometimes again data comes from different sources, so we might want to ensure that we have just a common data set that can be used by other stakeholders easily in order to inform them about maybe a solution that they're looking towards having for a research problem that they might be having. Data standardization, which is still tied to data quality assurance. So again, still data comes in different formats. And in order to ensure that we are able to even facilitate interoperability later, if, for instance, we want to move data from one, maybe electronic medical records system that stores data in one format to another one that stores in a different format, then we might want to ensure that we have data that's in a standard format. Maybe for data analysis, that's the other reason. Maybe you might want to perform healthcare data wrangling for data analysis reasons. Maybe you might want to have a clean, well-organized data set that would allow us to be able to extract meaningful insights and be able to make some actionable insights afterwards, or even just provide recommendations to other stakeholders. In some other situations, we might also prepare data or perform healthcare data wrangling because we want to create data visualizations that could go in reports. It could, those visualizations could go on web applications, or even just presentations that would be then used for just communication of insights to other stakeholders. So those are just a few reasons why we might want to perform healthcare data wrangling techniques. And yeah, so there are many of them, but those are just some few reasons. In terms of those techniques that we are talking about, these are just common healthcare data wrangling techniques that we can work with, which is the first one, importing data, filtering records. We might want to filter records in order to just focus on a subset of data that would allow us to answer a research question. Handling columns, we might want maybe to clean the columns, maybe replace certain column names with new column names, or clean those column names, maybe replace some special characters with characters that are well understood by many people. We might want to perform sorting in order to make some, say, to understand maybe what are the top values or bottom values when it comes to just comparison of just different records. We might want to maybe handle duplicates in case maybe there are duplicates within our data set, as well as handle missing values and outliers. So yeah, so generally that's just a quick macro perspective of what healthcare data wrangling entails. The next step that we are going to now take is to go through practice work. We've shared a link to the resources that we're going to be using for this workshop in the description section of the video. So if you check on the description section of the YouTube video, you'll find a link, a resource link that leads to a page that looks like this. Generally, we provide resources, and for this workshop, we've provided a free sample practice resource that you can be able to use in your learning journey. And the idea is that you're going to click on that link, the sample practice resource, and it should take you to, should open a new tab. It should take you to this particular page where we are going to be doing our practice work. If you're an Afterwork member, or if you want to become an Afterwork member and get extra resources that will enable you to to further understand the concepts that we have for this workshop, then you'll get access to the practice notebook as well as the solution notebook. The practice notebook has challenges for each and every concept that we are going to learn, as opposed to the sample notebook that only has just less than half of the challenges that cover the concepts that we're going to be covering. So if you really just want to understand how to just or you just want to understand what healthcare data wrangling with Python entails, and you don't really want to go that much deeper, then the sample notebook is a good choice. But if you want to learn a bit more, you can consider going through the practice notebook, and also you will get the solution notebook for just verification. So practice notebook and solution notebook are just available for Afterwork members. And sample notebook will be available to only those persons who do not necessarily want to go a bit more deeper in the learning process. So click on that link and you should get to this particular page. And the next thing that we're going to do is save a copy of this notebook, because this is a master copy. So click on File, then Save a Copy in Drive. It should open a new tab of just a copy of this notebook. You can close this one and work with now the other one. So just do that so that we are able to be on the same page. You can pause the video, by the way, and perform that process, because sometimes you might be moving too fast. So once you have done that, once you have created a copy, so you need to go File, Save a Copy. It will create a copy. The next thing that you're going to do is to connect this notebook to Google servers, which will be where our Python code that we will have in this notebook be run. So we will need to connect this notebook to Google servers. But before I do that, I don't want to make any changes to this notebook, so I'll just open it in playground mode. You don't have to do that. That's if you don't want to save a copy of that notebook. So once you have saved a copy of the notebook, you just click on Connect. So click on Connect to connect this notebook to Google servers. The notebook is just a document that contains analysis work that data analysts or data scientists use. And for this purpose, for this workshop, we're going to use this notebook to get to learn about concepts in relation to healthcare data wrangling. So once you have done that, the first thing that we are going to go through is data importation. That's the first set of concepts that we're going to get to learn about working with healthcare data. So the first concept, importing a CSV data set. So initially, when we want to work with Python, we would want to perform data manipulation or data wrangling. And we can write code to be able to perform those techniques, write code from scratch. But instead of writing code from scratch, we can use a library, which is just code that has been written by other stakeholders that we can use to perform the various tasks that we want. For this case, we want to, we decide to import the pandas library, which is a Python library for data manipulation. And we are going to be using it to perform just data wrangling techniques. So this line over here, so once you've expanded the different sections, expand the importing a CSV dataset section, and click on this link over here to run this code that's contained in this cell. So there are different cells. These are text cells and these are code cells. And we should be able to get an output. Well, we won't get an output for this case, but it will run. So this line over here, actually, let me explain. This first line is a comment, so it just explains what's happening. Anything that's after a hash will be treated as a comment. So import pandas as PD is the first line of Python code that will be run, and this will be the other line of code that will be run. So here we're importing pandas as PD, the pandas library, and we'll be using it when and we will use PD to be able to reference to the pandas library. So here we are referencing pd.readCSV. So the read CSV function from pandas PD, we will use it to read the dataset that's located in this URL, and we will enclose the URL in quotes, double quotes or single quotes. It's okay, you can use any. And the outcome of here, which will be just reading this dataset, will be stored in this df variable. And when we do that, we tend to call now this df as a data frame, because a data frame is just a tabular structure. It's a data structure in in Python that we can use in relation to pandas to store data temporarily and perform just data manipulation operations. So let's run that. If you get this pop-up, just know that you did not save a copy in Drive. I don't want to save a copy in Drive. Just wanted to do that. So here you can see there's a check. It means that our code ran, so we are good to go for that. We've actually stored df. We can preview it, but we'll learn how to preview in a few. So we have a challenge. Now load or import the CSV dataset that's located here into pandas, just like the way we have done here. So just apply that skill of importing a CSV dataset, and you should be able now to be comfortable when it comes to importing datasets. So once we've imported, we might want to display records, maybe the first 5 records. So for example, in our case over here, we could, by the way, the purpose of exploring the first 5 records, just generally to get a quick overview of the data and understand the structure and the content of that data set before going into some further analysis. So that's what we do. And here we are using df as a data frame. Here we will use data. We can rename the variable name. Doesn't make a huge difference, but you have just to reference it later. So we read the CSV dataset just like we did here, and then we decide to get the first 5 records. So run that to be able to get the first 5 records. We use head as the function for this case. So here we get this data set which has the first 5 records of this data set. So yeah, pause the video. I hope you also pause the video for this challenge. Pause the video and work on the challenge that you'll find here to so you'll be getting just different data sets, so you have to preview them. And note that every time we are going to be working with a data set, it's important to just preview the data set to see what's in that data set. So pause the video, work on the challenge, and once you're done, you can continue. But if you are an Afterwork member, you can verify your solution by going to the solution notebook. All right, moving on. Aside from the first 5 records, we can also explore the last 5 records. So we, instead of using maybe using head, we can decide to use tail. We don't even have to put a 5 in there. So we can use the tail function and it will get the last 5 records of this data set. But if you want to be more specific with maybe the last 4, you can put a 4 inside the parentheses for that function. And we'll get the last 4. As you can see here, we have the last 4 records. But you could also do the same thing for head. You could also decide to get the first 3 or the first 10. But again, sometimes if a data set is small, you may not be able to get more records. So like if it's 100 and this data set is quite small, you won't be able to get 100 records. You just get the records. Like this data set only has 5 records. So if you wanted 2, we could always do that. At this particular point, pause the video and work on example and work on the challenge on exploring the last 5 records. Moving on, we can decide to get a random sample of data in order to just have a fair representation of the records that we use for understanding the data set. So instead of, sometimes the first 5 records or the last 5 records might give might introduce some bias. So in order to ensure that we have a better perspective of how the data set is structured, so we could decide to use we can use the sample, we can get a random sample, and we usually use the the sample function. So we use the sample function, and we, inside the function, inside the parentheses, we define how many sample records we want. Like here we want 5. And you can see the records are just different. You get different records as opposed to what you're seeing here. So you might get maybe a different, and if you run the code, you'll always get just a different random sample. All right, pause the video, work on the challenge, and once you're done, we can continue to filtering records. So now we are done with data importation. Now we just have an idea of how we can import data from a CSV data source, and then how we can explore the first 5, last 5, and also get a random sample to just understand the structure. The next thing that we are going to now do is just understand how to filter records. So sometimes you might have maybe a data set that has 10,000 records, and we only want to work with maybe 100 records because they are they pertain to the research question that we have at hand. So we can do filtering, say, based on conditions. But let's first of all learn how to filter based on one condition. So filtering based on one condition, first of all, we can load our data set. This data set has an age column. We can preview it if you want, but we won't be doing that. The next thing that we want to do is to filter for where, filter records for where the age is greater than 40. So we would have this expression. So df, how to reference to a column would be, we would reference it by df, then square brackets age. You can also do df.age, and it has to be the same, but this is the best, usually most straightforward method. So df age is greater than 40, and then we define that we want to check for that in df, and then we filter. This will actually filter for those records with age greater than 40, store them in filter df. You don't have to say print here. You could always just also remove filter df so that you get a data frame as a result. So that's another one, and you'll see that age is greater than 40 here. All right, pause the video, and once you have worked on the challenge, then we can continue to the next concept. So once you have learned how to filter based on one condition, it's important to also learn how to filter possibly based on multiple conditions. Maybe you want also to filter based on another column, not just age. So how do we do that? It's almost the same concept as we did. Only thing is that in our case, we are going to say here, you see here we had one particular expression. So we can decide to have multiple expressions, but we would enclose each expression in parentheses. So we want to check for whether df gender is equal to female. You can also have this being less than or less than, like this is equal to. You could have less than, you could have less than or equal to, or greater than or equal to, or not equal to. That's not equal to. Those are just different operators that allow you to be able to do some of what you want. So if gender is equals to female and df income is greater than 60,000, then so the idea here is that we want for records which have gender in the gender column, the value female, and an income greater than 600. So we use an ampersand. An ampersand, it just ensures that both conditions are right for that to be the case. So, and we store the outcome of this inside filter df, and then we print out the data frame. We can remove the print function, we don't necessarily need it. So, and these are the records for that based on that conditions, those multiple conditions that we have. All right, at this particular point, pause the video, work on the challenge, and then we'll continue to the next step. Sometimes we might want to, work with columns. Like, we might want to clean columns or select the columns that we might want for analysis. So generally, which is part of also data wrangling. So let's learn how to just be able to perform just different operations on columns. So initially, you might want to rename columns to just be able to just change the name of those columns to maybe some desired column names. So initially, the idea would be that the data that we would want, or the column names that we would want would be easier to work with. Say, for example, in our case, maybe we might want to replace patient ID, which has a space, with one that doesn't have a space, first name with one that doesn't have a space. So the space is replaced by an underscore. So how do we do that? So this is our data set that we have here. the first method that we can use is to use the rename function, and inside the rename function, we can be able to define the columns that we want, and the value of columns is, would be a dictionary that has key, like, key values. So the key for the key would be the initial value that's there in the data set, and the value would be now the new value. So first name, first name, last name. So here we are replacing patient ID with patient ID, this new value, old value, new value, old value, new value, and we can continue that to the point that we want. It may not be the most efficient way, but it could also come in handy. This other bit, this is the first method. We could also use this other new method where we decide to define all the column names that we have. This is especially when we have shorter or smaller data sets, not shorter, but smaller data sets. We would define new column names inside the list, and then store that, say, inside the list, so new columns, and then we would say df.columns. So when we reference df.columns, we actually are referring to the existing column names, and we store now the new columns, and we replace the new columns with the old columns with the new columns, and that would be it. Alternatively, we might decide to rename just specific columns using this first method, but again, you need to ensure that the key actually exists within your data set, and then we can preview that. So you can see the new columns have an underscore, between underscore for the column names. Right, pause the video, work on the challenge, and then we can continue. We can also decide to convert column data types. So sometimes you might have column data types that may not necessarily work best for maybe further analysis. So you might have maybe a certain column, maybe age, that has been stored in a float column, in a float format or a string format. And by the way, data types are just classifications that we give to just whatever. It could be variables, it could be columns, and those classifications allow us to just perform operations. It could be mathematical operations, other operations, maybe such as data cleaning. So, for example, in our case, we might want to convert maybe the age column to an integer. So we would use as type function, and then we would define what the type of data type that we want to convert it to. So int, we want to convert we want to convert the age column to an integer, dosage column to also a string, and preview all that. So let's run this. So here I could even just display, okay, let's just see this. So age is an integer now. So age has integer int 64. Dosage to a string in Python, that will be an object or an object. So dosage here has a now data type object. And you could also do float as well in that situation. So yeah, so that's just a quick idea of how you can be able to perform data type conversion. So pause the video, work on the challenge, and once you're done, you can continue. So we don't have any other challenges for person sampling the course. But if you want to continue sampling the course, feel free to just follow through the video and also modify the existing examples. But for Afterwork members, you could always be able to, we have practice work that allows you to be able to maybe convert column data types. Like, we have this convert the income column to the data set, the data set to integer data type, etc. So you can always do that. But for persons who just want to go through and see what happens then in relation to healthcare data wrangling, then we can continue with what we have so far. All right, replacing column values is the next thing. Once you have finished working on the challenge, then you can continue. Replacing column values. So sometimes you might want to replace maybe certain values within a column, and which might be representative of what we want. Maybe in the diagnosis column, we might have high cholesterol, but we want, but hyperlipidemia actually works best for high cholesterol as an alternative. So how do we replace those values? So we can decide to say, use the replace function. So we have this replace function that you find here, and this replace function takes in two different inputs, so arguments. So there's this dictionary which will contain key value pairs. By the way, when we are talking about dictionaries and key value pairs, check out the healthcare, or check out the Python fundamentals with healthcare data, Python fundamentals for healthcare course that we already have, to just get a good idea of how to work with just Python fundamentals before you come to this particular course. This is the next course after that. So we pass this dictionary, which will contain old value, new value, then comma, old value, new value. Then we set in place as true, so that we apply the changes that we have in this particular operation to the original data frame which we had here. So the new values will be as shown here. We also do the same thing for our medication column, and also for doctor. So we have new values. So like we won't see Dr. Smith anywhere inside the doctor column. We'll see Dr. Brown. So you can see here we have Dr. Brown. We don't have a Dr. Smith somewhere. Same case with a Dr. Johnson. Okay, selecting one column. Sometimes you might just want to select one column and just work with that column only. And how we do that is just we define. Well, first of all, we can load the data set. Then we say df square bracket diagnosis to specify the column that we want, and then we can just work with that. But then we just want to store it in diagnosis variable, and then print it out, display it. All right. And by the way, if you see it as like that, you can also add a reset index function to preview it in a data frame format. So, but may not necessarily work. It introduces some other data, but yeah, you can still do the same thing. So I think you've also seen how we've referenced this column in other situations. Like we've also done it in this situation. Even in the previous situations of expression of filtering, where we also reference the actual column itself. So right, we are here selecting one column. So pause the video, work on the challenge, and then once you're done, we can continue. Selecting multiple columns. Sometimes you might want to select multiple columns, not just one column. So instead, what we would do is to, as you can see here, we have diagnosis. Oh, by the way, you can also get a data frame by just putting a square bracket. Sorry, I should have mentioned that instead of even using reset index. You can put a square bracket. How do we do this? Double quotes. It could be single or double quotes, doesn't matter. So we can also get a pandas data frame format, as you can see here. If you use reset index, you will get something else. But if you wanted multiple columns, we'll just have a comma here, and then we have our next column, etc., etc. So multiple columns, that's actually what we do here. We want to select name, age, diagnosis. So we have a list inside here. Then we reference the data frame that we are working with. We have name, age, and diagnosis, and we can be able to work with this data, maybe for visualization or for other purposes. Awesome. So right, so we can move on to the next set of concepts once you have done the challenge. So pause the video, work on the challenge, and once you're good to go and you verified the solution, then we can continue with sorting. Sorting in ascending order. Sometimes you might want to sort values within a data set so that we have maybe values from in a specified column arranged based on a specific column from maybe smallest to largest. So we can do that using the sort values function. So we might, load a data set, but want to sort by age. So we use the sort values function, and we define that we want to sort by age, comma, then we say that we want to sort by ascending order. So this is important because it allows us to just be able to sort by ascending order. So if I run this, I should be able to see that our data frame has the records have been sorted based on age in ascending order, 25, 30, 35, etc., up to 70. In descending order, it's almost just the same, only that here you're just going to change that to false. So this is another data set. We decide to sort this data frame in by total charges is another column, and then we change this to not true to now false. So, and the reason why we would want to sort in descending order, maybe we might want to have maybe highest values first, or maybe when we want also to rank maybe some data, maybe from highest to lowest. So total charges, so we have 8,000, 7, 6, 5, 5, 4, etc. All right, pause the video, work on the challenge, and once you've done that, then we can continue. Duplicates. So sometimes some data sets might contain duplicates for various reasons, but we need to first of all identify whether there are duplicates within our data set before performing further analysis. Otherwise, our results might be wrong if we just perform analysis without considering whether there are duplicates in our data. So so let's first of all understand how we can be able to get duplicate records. So we can do that using now the duplicated function. So we have this duplicated function, and we can even define duplicates based on maybe a certain column, like phone number column. If we don't have to consider this, but in some other situations we might want to do this. So if we don't, we can remove that, and we can just define the duplicates that we have within the data set, which we don't have. But if we want to define duplicates based on a certain column, such as a number column, we would pass subset parameter inside duplicated function. So subset phone number, then keep false. So we will be able to keep all duplicates. So if I run this, I should be able to see what I have. It seems actually I don't have any duplicates, and you could always just investigate further. Maybe I can say df. Let me just display df and just to see like how the data set looks like. This is how the data set seems, that they all have the same unique values. This might have not been a good data set, but yeah, so I think that gives you a good idea of how we would have gone about it using the duplicated function. So you can pause the video, work on the challenge, and then once you're done, we can continue. Removing duplicates. So once we have identified that they are duplicates, how can we clean them? So we can clean them as shown. So we can use the drop duplicates function, as you can see here, and we would define we want to drop duplicates based on maybe patient ID, etc. So here we have the original data set. This is the other new data set after remove of that, and I can even remove just the print function. So this is the original one, this is the new one. So even in this case, we don't have duplicates, it seems. But again, this function should allow us to not have duplicates in our data set. So here it's because all the patient ID names are just different. So you wouldn't be able to find that. I'm just trying to look at even gender, but we could actually do with gender alleges. I'm just trying to see whether we can do. Oh, these are unique. Maybe gender. Let's try gender, and you should see a difference based on the gender column. Should have just a few. Good, gender. No, gender. Yes, you can see at the very bottom we have 2 records which have been retained. That is, it considers all these other records duplicates, based on the gender column. So only 2 will be left. So if you have duplicates, then they will be removed. But if you don't, you could always just use if you want to use the entire all the column names, you can just pass it as that drop duplicates, and you should be able to just in case there were just duplicates, intentional duplicates all over. But using just the patient ID makes sense, or even just a phone number, because sometimes you might have duplicate records. Or alternatively, you could decide to merge those records that you might have as duplicates. Pause the video, work on the challenge, and once you're done, we can continue. Missing values. Sometimes data sets can come with missing values. So how do we find those missing values and deal with them later? By the way, we have a dedicated course for this. So finding records with missing values is something that you could always cover in length or extensively in another course that we have. So you do not necessarily have to mind a lot while we're only covering just a few concepts. So finding records with missing values in a data set just allows us to identify and be able to later onwards decide how to handle incomplete data. So initially we load this data set, then we use the isNull function, and we apply it to the data frame to be able to identify those missing values, and then we get the records with those missing values by passing missing values.any and defining the axis, and we store the outcome in missing records. So that's what you have there. We could also check for missing values. So we could decide to, so here we just have the records themselves, the ones that have missing values. But initially you might just want to check which columns have missing values and how many of those values are there in those columns. So we can use the isNull steal function. Then we apply the sum function to the outcome, and we store that in missing values and display it. So here we can see that we have in the ID column, we have 0 missing values, a name 0, in age 1, gender 0, income 3, etc. This is an easier way of just identifying missing values as opposed to this other one. So you might want to run this first before going to this one, before getting those records with missing values and investigating them further. And the action that you might do as a result of this particular process, it's dependent on your domain expertise. Sometimes you might realize maybe you could impute or give realistic values based on what you would think as an expert makes sense. Or sometimes you might do that replacement based on a mean or a mode of the rest of the values or the records in that data set, or only the records that are much more representative of the missing value that you're looking towards. So let's just learn how just to remove records with missing values. But this might be also suitable if maybe the idea of removing those records does not significantly affect the overall outcome or the analysis itself. So removing records with missing values, so we might decide to do that. So how do we do that? So we could decide to use, yes, we identify the missing values, but we could also decide to just use drop NA. The drop NA function will just drop everything, and it will everything with missing values, any NaN, and then you'll just be left with now the clean data set. That's just another way of doing that. This line we may not necessarily need, but you need this 2 lines. So here, so this new data frame is a clean one. It doesn't have missing values. This one would have missing values. All right, at this particular point, pause the video, work on the challenge, and then once you're done, we can now work on the last data wrangling technique in relation to healthcare data wrangling. That's working with outliers. All right, so finding and removing outlier records. Sometimes some data sets might have records that have columns which are way above the norm. So a certain record maybe might have a patient who's 192 or 200, which of course patients don't live to get to that as of 2024. So how do we go about that situation? So we might decide to find and remove those records and delete them. So, but in some other cases, we might want to impute them with realistic values, or which we might get from either maybe from a different data source, or even just asking the respondent directly if you're able to. So, but again, it's a decision that you as an expert would have to make. So starting off, we might want initially, first of all, to identify outliers. And there are many ways we can identify outliers. But to be able to identify outliers, we can use one of the common methods. There's the IQR method, and there's also another method called the Z-score method or Z-score method, which we're going to be learning. And this method measures generally how many what are called standard deviations a data point is from the mean. So if a record has a value within a certain column that has many standard deviations from the mean, than is the norm, then we can treat that record as an outlier. So the Z-score will help us be able to identify those outliers in that data set. So for this particular case, I'll actually copy this separately so that we have a good understanding of how that data set looks. So I'll just preview this data set here. You can always do the same thing, doesn't really matter, but this is just to give us a good idea of the data set itself. So we have this data set has blood pressure 120/80, etc. But assuming that we also want to use the values for blood pressure, we could decide to split now the blood pressure column by saying want to split the value where there is a forward slash. So we use str.split and we want to expand it so that we have separate columns. We want to see systolic and diastolic new columns. So the first value will be put into systolic or systolic, and the second one will be diastolic, dystolic. So yeah, so we would have new columns as a result of that, and then we would need to convert those columns into numeric form. So so that we are able to perform mathematical operations on them, like performing or calculating Z-scores. So once we have been able to do that, we can decide to calculate maybe Z-scores for maybe systolic blood pressure, and we can have that as shown here. And then we can decide to also now define maybe a threshold for the Z-score, because that is also something you would have to define. Like a Z-score is something that like the threshold for what you would treat outliers as is something that you would need to set by yourself. So we can decide to have outliers to be those records with a Z-score of or base, which is the systolic Z-score of greater than or less than -3 or +3, or more than +3, more than 3 times. So standard deviations from the mean. So so in our case here, we can decide to remove, say, outliers based on systolic Z-score that's greater than 3, which we do. And then we maybe in our case here, we're just dropping the intermediate columns, and then we're displaying that. So that's another alternative of just being able to define that. So you can also, in this situation, you would also have to maybe check other columns as well. But there's also another method that you can use. It's called the IQR method. We've covered that in another course called Data Wrangling with Python course. So you could always check that out. But this is just one of those methods that you could use for just identifying outliers. So at this particular point, pause the video and work on the challenge if you're an Afterwork member. And then once you're done, then we can continue to the next steps. Right, so once you have completed the challenge and verified your solution, the next step, usually after you've gotten to have gone through a data wrangling with Python course, such as this one, this pertains to healthcare, is now to get to just learn a bit more deeper about some of the concepts that we've covered. So how do you handle missing values in different ways? So we've only just scratched the surface of missing values. The same case with outliers. So, but our recommendation is that you go through a workshop on either handling missing values with Python when it comes to healthcare data. Alternatively, you could also do data filtering. It's one of the concepts that we've gone through. There are different filtering techniques that might come in handy in your career if you would want to go further into healthcare data analysis or to just work with healthcare data. So data filtering with Python, healthcare data filtering with Python, that would also be another alternative, or finding handling healthcare missing data with Python would also be another alternative. You could also decide to go through just a course purely, which will just refresh what we have gone through purely on healthcare data cleaning. There's a slight difference between data wrangling and data cleaning, but a data cleaning session would just involve just cleaning data properly, like just working on, still you'll get to work on finding missing and finding and handling missing values as well as outliers. Same case with duplicates, but you may not get one that concepts in relation to sorting, filtering, selecting data. That may not necessarily be covered in healthcare data cleaning. So healthcare data cleaning will cover just cleaning aspects. The idea is that by the end of it all, you should be comfortable enough to prepare data for further analysis, whether it's visualization or just basic data analysis in Python. Then you should be in a good position to do that. And again, it's important, something that I might have forgotten to mention to you, while you're performing all these different techniques, you would document whatever steps that you've undertaken in the process of data cleaning. We also have projects that you can do, by the way, on our website. You can visit some of those data wrangling with Python courses that we've created. There are projects that you can be able to do that will also help you to feel what it takes to work on a healthcare data wrangling project with Python and have acquired that skill. So that's it. So that's it for this particular course. If you liked this course, be sure to give it a thumbs up if so that other people can be recommended. If you also would want to be informed of future such courses that we post on or stream on our platform, and that's on the YouTube platform, be sure to subscribe, and also see you in the next course that we get to